This is Algebra 1, Lesson 3.1. We're solving equations using addition and subtraction. Those are our goals, to solve linear equations using addition and subtraction and do it in real-life problems beginning on page 132. Got a few definitions to start. First one is, what are equivalent equations? Equivalent equations are equations with the same solutions as the original equation. So when something is equivalent, like x plus 3 equals 6, that is equivalent to x equals 3. This is equivalent to this. And we'll talk about why those are equivalent in just a minute. Inverse operations are the operations that undo each other. Addition undoes subtraction, and subtraction undoes addition. The same thing is said when we get to multiplication and division. Multiplication undoes division, and division undoes multiplication. Those are the operations that cancel each other out. A solution step is every time in a problem you write something different. It's a solution step. For example, the one I said a second ago, x plus 3 is 6. That's the original problem. When we write it the next step as x equals 3, that's after subtracting 3 on both sides, again, which we'll talk about in just a minute. This is a solution step. This is a one-step equation. It shows the transformation from x plus 3 equals 6 to x equals 3. It doesn't show the operation. It doesn't show the subtraction of 3, which we'll do that in a minute, but it shows the solution step. A linear equation is anytime y is equal to x to the first power. Remember, you never write anything to the first power. It's understood as being to the first power. That is a linear equation because it is a straight line. Here are transformations that produce equivalent equations. The first equation is x minus 3 equals 5. In order to undo minus 3, you add 3. If you add it to one side, you need to add it to the other. So adding 3 to both sides is a transformation, plus 3. When you add 3 to both sides, you get 8. The reason you have to do stuff to both sides is you need to think of an equation. Remember, an equation means anything with an equal sign in it. You need to think of an equation as something that needs to be balanced. The equal sign is the balance point. And I know in your textbooks they have a picture of this. But these are the old-time scales. Your equation is your balance point, but your scale needs to be even on both sides. That means whatever's hanging over here has to be hanging over here. So if, like a second ago, adding 3, if you put 3 more on this side, it's going to go down because it's not balanced anymore. The only way that you can change that to where it gets back to being balanced is anything you do on one side, like add 3, you have to make sure to add it here. Now it's the same weight again. So any operation you do to one side, you have to balance it out and do it to the other side. The next transformation that produces an equivalent equation is subtracting the same number from each side for the same reason. There's your balance point right here. X plus 6 equals 10. There's your balance point. In order to undo plus 6, you subtract it on both sides. 6 minus 6 cancels it out. That's what you were trying to do. You were trying to undo it and give you just x. 10 minus 6 gives you 4 in that case. So subtraction. And for the same reason this was right here. Adding 3 made it heavier on one side, so you had to add 3 to the other side. If you were to subtract 6, if you took 6 away, it would make it lighter on that side. So in order to make this one balanced, you got to take 6 away on that side as well. You got to do it on both sides. The next transformation, It's simplifying one side or both sides. Okay, this makes an equivalent equation, but notice x is already by itself. In these first two examples, x has something subtracting from it and something adding to it, respectively. In this example, x is all alone. It's isolated. You don't have to do anything to x. You simply have to do 8 minus 3 and get 5. You don't do it on both sides because it does not change. It does not throw the balance on your scale off. And then the sides are interchangeable. 7 is equal to x is the exact same thing as x is equal to 7. Here's example number 1, adding to each side. On the left side of the equation, 9 is subtracted from x. To isolate x, you need to undo subtraction by adding the inverse operation, or adding 9. Remember, anytime you add 9 to one side, you have to add it to the other side. So x minus 9 becomes x plus 9, and this is solved out horizontally instead of vertically. Most people, when they do this, prefer to say plus 9 underneath it, plus 9 underneath it. That's just two different ways to get to the same result. This one here will cancel out. This will cancel this. And then negative 20 plus 9, opposite signs, you subtract them. 20 minus 9 is 11, and 20 is the bigger value, so it's going to be negative 11. So therefore, the solution is x equals negative 11. You can check your solution by subbing it into the original equation for x. So right here, sub it in. Negative 11 minus 9 equals negative 20. And if you get a true statement, then it is a solution. Negative 20 is equal to negative 20. On the back, solve this one. X minus 9 equals negative 17. Take 30 seconds. All right, x minus 9 equals negative 17. Here's your balance point right here. We want to get x equals all by itself. We don't have that. We have x minus 9. So undo minus 9 by adding 9. If you add it to the left side, you got to balance it by adding it to the right side. Opposite signs, 17 and 9. Subtract them. 17 minus 9 is 8. 17 is the larger absolute value. It's negative, so negative 8 is what you should have. Example number 2, it's simplifying first. So first we have n minus a negative 8. Anytime you have minus a negative, remember that means plus a positive. So n plus 8 is equal to negative 2. Undo plus 8 by subtracting 8 on both sides. Again, this is the horizontal method. This is the vertical method. To subtract 8 on both sides, it cancels out here and leaves you with just n. Negative 2 minus 8, same signs, add them up. 2 plus 8 is 10. Keep the common sign negative. N is negative 10. On the back, this one, negative 11 equals n minus a negative 2. 30 seconds. Okay, we have n minus a negative 2. We still got ourselves a balance point right there. Minus a negative means plus a positive. If you need to write them in, do it like that. Plus a positive, n plus 2 equals, we still got negative 11. Don't lose the negative. We want to get n all by itself. We don't want something adding to n. So it says plus 2. We subtract 2 right there. If we do it on the right, make sure you balance it and do it on the left. Same sign, 11 and 2. Add them up. 11 plus 2 is 13. keep the common sign negative. N is equal to negative 13. Let's look at your checkpoint problems real quick. X minus 7 equals negative 15. Balance point. Add 7 to both sides because you're undoing minus something. X equals negative 15 plus 7. Opposite sign. Subtract them. 15 minus 7 is 8. 15 is the bigger sign, bigger absolute value. Keep that sign. N minus a negative 6 plus a positive 6. N plus 6 is 4. Balance point. Get N by itself. Undo plus 6 by subtracting it. Do it there, you got to do it here. Opposite signs. 4 minus 6 is going to be negative 2. 10 plus y. Okay, this one's written backwards. If you have to, you can rewrite it. You can use a commutative property and say y plus 10. It's unnecessary, but if you have to see it, that's fine. Balance point is here. Undo minus 10. If you do it there, do it here. Same signs. Negative 10 and negative 7. Add them, you get 17. Negative is their common sign. Y is negative 17. Do these for homework. Screwing around.